Today, we will be talking about problem solving and its impediments towards solving a problem, its objectives. In this lesson, we will focus to learn on meaning and the definition of the problem solving. We also will learn about problem cycle, types of problem solving. Let us understand this with definition. When do people think? What makes them think? One of the major stimulants to thought occurs when a person faces problems. Some people specialize in solving certain problems. Expert chess players, for example, Vishwanath Anand, can construct the positions of 25 chess pieces after looking at the board for only 5 to 10 seconds. Problem solving has been defined as an activity that takes place in an unfamiliar context when a motivated person is initially unsuccessful in achieving some goal. By Erikson and Jones in 1978. By studying thinking or cognition during problem solving, many human experimental psychologists believe that insight may be gained into the basic character of human thought processes. The information processing approach to problem solving treats the problem solver as a computer information processing system with 4 stages. The first stage, the person perceives the problem and converts it into a set of propositions in working memory. Since the capacity of working memory is limited, errors may occur because parts of a complex problem are overlooked. This may be particularly true if a person is unable to use some strategy for remembering, writing the problem down, or clearly identifying its nature. In the second stage, it involves searching long-term memory for a solution or for information that will help the person construct a plan or production system to arrive at a solution to a very similar problem solved in the past. On the other hand, it may be necessary to construct an entirely new solution based on inferences and recombination of prior knowledge. In the third stage, this stage consists of executing the potential solution the person has developed in the stage 3. If the potential solution is simple, this stage may be carried out quickly and easily. However, it is complex, the execution process itself may lead to errors. Fourth stage, finally, in the last stage, the person evaluates the results by comparing the outcome with the goal represented in memory. This permits the person to judge whether he or she has completed the task or must continue to search for a solution. If the problem has been solved, the person may focus on identifying cues that will permit retrieval of the solution at a later date. If the problem has not been solved, the evaluation process may suggest the nature of the inadequacy. So now let us understand it through the stages of the problem solving, which is given by Harvard in 1983. Similarly, this can be explained with problem solving cycle. Problem cycle. The problem cycle consists of few stages. In the process, the first stage is identifying the problem. It is very important for one to recognize the presence of the problem for a possible solution. Identifying and naming the problem is an challenge as getting a solution to it. It can be one of the major hurdles which does not allow the individual to think further, creating obstacles. Introspection is key in identifying the problem as to ask more and more questions to yourself to see the depth of the problem and figuring out the causes and effects of the problem. Exploring possible strategies. The second step in the cycle is the research the problem as fully as possible and to explore possible problem solving strategies from every possible perspective without leaving any rudiments. A lot of brainstorming, visualizing, creativity, analyzing capacities are required to generate a potential solutions. Set goals. The powerful process of thinking is setting goals in which an individual thinks about a vision and plan accordingly for their ideal future by designing a route map. In the process, the questions like what, how and where and by when I will be in future can answer your questions with a suitable solutions. It requires tremendous effort in planning a SMART goals, which means specific, measurable, achievable, relevant and time bound. Look at alternatives once the goals have been decided and set. One needs to look for an appropriate approach towards reaching it, and then an individual should look for another option as well as an alternative to compile a list of possibilities which will help a smooth way to discover effective solutions rather ending in despair. Most of the best solutions results out of a creative and brainstorming which can be a source of information from family, friends, counselors, books, researches, cases. Having more ideas can make the goal set happening with less ambiguity. Select a possible solution. From the list of options available from the ideas after setting a goal, one need to choose the best fits into the problem and also give the reason as why the option chosen is best among all the rest of them. The most relevant option after sorting by exploring at current situation, thinking it as realistic and manageable through which one can predict the outcomes for possible solutions and also verifying it with other expertise. Implement a possible solution. Another important task to be done in implementing or applying the selected solution for the best created into action. This part will allow an individual to establish and connect people as who can be of best help in making the plan productive. The larger goals can be formed into immediate sub-goals for seeing its effectiveness in terms of rewards and how will it be benefiting from now to then. Evaluate the results. After a solution has been reached, it is important to evaluate the results to determine if it is the best possible solution to the problem. Decide how you will quantify the success of your problem solving strategy. Questions are: how effective was that solution? Did I achieve what I wanted? How do I know this? Now let us understand with the process of problem solving in types. Rigidity. Often people fail to see the solution to problems. One reason for this that they fixate on one aspect of the problem, ignoring others that are relevant for success, a difficulty labeled as rigidity. There are several types of rigidity. A continued use of a solution that has worked in the past but which is inefficient or ineffective in the current situation. This is called as a response set. The best solution to the first several problems involves the following procedure. Fill picture B, then fill the picture A from picture B and discard. Next, fill picture C from picture B twice and discard. The water remaining in picture B is the goal amount. People generally continue to use this solution for all the problems even though the last two problems are solved more efficiently by using only pictures A and C. If problems 6 and 7 are presented first, people notice the simpler solutions, but when they are presented last, people's previous experience tends to misdirect their focus to the more complex solution. A second type of rigidity involves a tendency to perceive a problem from only one perspective, a tendency labeled perceptual set. Consider a classic problem developed by Duncker in 1945. The correct solution is to 1. Empty the box containing the tacks. 2. Attach the box to the wall using several of the tacks. 3. Light the candle and allow some wax to drip from onto the box. And 4. Affix the candle to the box by embedding it in the melted wax. However, since the box is full of tacks, people often fail to see it as having any other potential user. Duncker called this functional fixedness. If the box is presented empty, people generally solve the problems more easily. Incubation and insight. Sometimes a rest interval between period of work on the problem will increase the likelihood of its successful solution. Everyone has experienced the effects of such incubation. The name we struggled to remember suddenly seems to pop into consciousness without effort minutes or hours later. A strategy for organizing a term paper suddenly becomes clear days after one has given up in frustration. Incubation seems to occur only after the person has devoted considerable time and effort to the problem. It also seems to often be accompanied by a flash of insight, an aha experience characterized by a feeling of certainty that the solution is correct. We should note, however, that incubation and insight have been difficult to demonstrate precisely under controlled conditions. The evidence for these processes is largely anecdotal. Strategies. When presented with relatively simple problems, one may use several alternative and different strategies to find a solution. For example, consider the Tower of Hanoi puzzle by Simon in 1975. Here, the problem solver must move a pyramid of discs from one to another of 3 pegs. However, the rulers are that only the top disc on any peg may be moved and a larger disc cannot be placed on a smaller one. Many different strategies may be used to solve this problem. Some useful strategies depend on expert knowledge. Perceptual cues are used to solve this problem. Some useful strategies depend on perceptual cues, others on setting superordinate and sub-goals, and still others on following a pattern. For example, a pattern following strategy useful for solving the Tower of Puzzle would be to move the disc in the order 1, 2, 1, 3, 1, 2, 1, 4, 1, 2, 1, 3 and so on. Thus, problems such as the Tower of Hanoi involved transforming a stimulus from an initial state of final one. As such, these problems are quite useful in exploring the strategies used in problems of means-ends relationship. They allow the cognitive psychologist to understand the different strategies, means that human beings use to solve a problem, reach an end. Most research on problem solving has used volunteer college students as participants. The tasks used in these cases do not call for much, if any, specific prior knowledge about a given problem. However, often in life, people specialize in solving one or another type of problem. Some people are experts at games such as chess. For example, many students have been undertaken to examine problem solving by expert chess players. The questions asked in such research are: 1. What kind of knowledge must an expert have? 2. How is that knowledge stored in long-term memory? And 3. What perceptual cues, if any, evoke this long-term memory? The classic work of de Groot in 1965 discovered that chess master could reconstruct the board position of about 25 pieces after viewing the board for only 5 to 10 seconds. An ordinary player could remember only about 25% of total after the same exposure. Semantically rich domain. This area of problem solving is related to expert knowledge. That is, the experts have extensive knowledge about solving a particular type of problem, and a semantically rich domain in a problem area requiring extensive knowledge of solving problems. In the study of semantically rich domains, there are two central research questions. First, how much knowledge in long-term memory does an expert have? Second, what is the organization of this knowledge and how does the expert gain access to it? Besides chess masters, these questions have been studied with experts in field as diverse and chemical engineering, thermodynamics and medical diagnosis. Production system. How do we know that stimulator ideas seemingly suddenly retrieved from long-term memory function to change human thought? Although a final answer to the question is not possible for formulate cognition or cognitive psychologist study of production systems appearing to be a step in right direction. A production is simply a set of instructions. It has two parts. First, a condition is a sort of test. The test may be 1. A perceptual one, asking is a stimulus is a particular sort, example a word or a random arrangement of letter, or 2. A symbolic one, asking if a set of symbols, again for example a word matches knowledge held in short-term memory, if appropriate condition is met. If the test is passed, the second part of the production occurs. This is the action. For instance, if the perceptual test of word is passed, the action of recognition of the word will occur. Understanding process. Before someone can begin to solve a problem, he or she must understand its nature. That is, as Simon reminds us, a problem well formulated in half solved. In recent years, cognitive psychologists have begun to explore the process involved in the initial understanding of a problem. One major finding has been that skill gained in solving one form of the problem will not always transfer to comparable forms of the same problem. By Green in 1975. Second, even minor changes in how a problem is presented, changing the tense of the instructions, for example, can considerably alter a solver's ability to deal with the problem efficiently. Hayes and Simon in 1976. Let us summarize. Problem solving makes use of cognitive processes to achieve a goal. To solve problems, a person's thinking involves a level of consciousness to their thoughts. It can be directive thinking about a specific goal or more indirective and may use having different expectations of knowledge. Originally, behavioristic thought that problems were solved through trial and errors. Subsequent approaches include the Gestalt approach and the information processing science approach. It is both reproductive and productive, wherein reproductive uses its previous experiences and productive involves in sudden insight into the structure of the problem, helping it for further reconstruction. Problem solving is a very serious and a thoughtful action which involves unique approaches for higher order thinking and systematic scientific steps to comprehend and set goals. The scientific steps involved may be identified as problem awareness, problem understanding, collection of relevant information, formulation of hypothesis and selection of a proper solution.